Greetings class, I hope I find you well. In today's lesson, we are going to be focusing on June 2017 paper 1 SIMSEC, pure mathematics. We are going to start with the first question. It reads, on the same axis, sketch the graphs of y is equals to modulus of x minus 1 and y is equals to x, 2 marks. So I'm going to start with y is equals to modulus of x minus 1, right? You prepare a table of values to identify the points, right? Firstly, we want to calculate the value of y when x is 0 and the value of x when y is 0. I hope you are following, right? So placing 0 on x, you get y is equals to modulus of minus 1. So a negative sign inside the modulus disappears. So it means modulus of minus 1 is good as 1. So when x is 0, y is 1. So this is your first point. We move on to the next. We want to find the value of x when y is 0. So you are saying 0 is equals to modulus of x minus 1, right? So if we have a 0, we can ignore the modulus since square root of 0 is 0. So you get 0 is equals to x minus 1. 1 is equals to x. Meaning to say when y is 0, x is equals to 1. This is the second point. Right. So you have 1 here. Then you have 1 here. 0, 1 and 1, 0. Right. So if you plot the modulus, you get a V-shaped graph like this, passing through 1, 1. You need to sketch it in such a way that the slope on the left side is equal to the slope on the right side, in terms of the angle being formed by this slope with the x-axis should be equal to the angle being formed by this slope with the x-axis, something like this. Right. Then the second graph to be plotted is y is equals to x. This one is simple. It passes through 0, 0. It also passes through 1, 1. When x is 1, y is 1. When x is 0, y is 0. So we have 0, 0 already. Then 1, 1. This is 1, 1. You put a point. Then you draw. It comes out like this. It comes out like this. So this is y is equals to x. And this is y is equals to modulus of x minus 1. This is how you draw it. Right. So I want you to notice something that having y is equals to x, it means you have got a gradient of 1 here. Gradient is the coefficient of x when y is the subject of the formula. Same applies. Y is equals to modulus of x minus 1. The gradient was 1 on the positive part of v. So it means that this line in this right part of v of the modulus graph, they are moving in the same direction. They are parallel to each other since they share a common gradient, which is 1. So there is only one point of intersection between the modulus graph and y is equals to x. This is the first part of the question. Right. We move on to the second part of the question. Hence or otherwise, solve the inequality. Modulus of x minus 1 is less than x. Right. So here I'm going to write modulus of x minus 1 is less than x. You start by raising both sides with power 2, right? So raising both sides with power 2, you get x minus 1 squared minus x squared is less than 0, something like this. Then you carry out difference of two squares. You carry out difference of two squares to find the critical values. Square root of x minus 1 squared, you get x minus 1. You put a negative sign. Square root of x squared, you get x. But in this bracket, you get x minus 1 plus x, something like this. I hope you are following. Right. So x minus x here, you get 0. So on the first bracket, you'll be left out with minus 1. Then x plus x, you get 2x. So this is 2x minus 1. The second bracket is equals to 0. So to solve this equation, you start by dividing both sides with minus 1. You get 2x minus 1 is equals to 0. Therefore, x is equals to half, which is representing our critical value. So it simply means that the point of intersection between the line y is equals to x and the modulus function, we have half here at their point of intersection. I hope you are following, class. Right. So to then solve the inequality, since they are saying modulus of x minus 1 is less than x, remember the modulus graph is being represented by the blue ink, and the x graph is represented by the black ink. So when they are saying modulus of x minus 1 is less than x, they want you to give the range of values of x at which the blue line is below the black line. The black line is your x. The blue line is your modulus. So what is the range of values of x for which the modulus is below the black one? So you can notice that the blue line is below the y is equals to x when x is greater than half. So starting from half onwards, you have the blue line below the black line. So it means the final answer is x is greater than 1 over 2. This is the hence part. Right. Then the otherwise part is, once you get your critical value, you draw the x-axis, you put your critical value half here, then you draw a dotted lines. So since we have one critical value, it means we are going to have two regions. The right side is x is greater than half. The left side is x is less than half, something like this. Right. So let's say you have a 0 here, right? The 0 is in favor of the left region. We want to see whether 0 is going to be true or false, right? So you go back to this stage and substitute 0 on x at this stage. So putting 0 on x, you have minus 1 in the second bracket and 2x is going to disappear. Minus 1 times minus 1, you get 1. So according to the inequality, we have less than 0. So for 1 to be less than 0, it's false. So it means this region is not true. The correct answer becomes x is greater than half. So this is the otherwise part. And observing the graph is the hence. I hope you are following. So from the graph, you can clearly notice that the blue modulus is below the black modulus for x is greater than half. Right, we are now moving on to question number 2. It reads, if f of x is equals to 3x cubed plus x squared minus 8x plus 4, factorize f of x completely. 4 marks. Factorize f of x, you need to find a number that when placed on x, the entire function gives a remainder of 0. So you start by searching with 1. You start with f1. You get 3, open bracket, 1 cubed, plus 1 squared, minus 8, open bracket, 1, plus 4. Right, so if you punch this in your calculator, you get 0. So this 0 indicates that x minus 1 is a factor. If f of 1 is giving you 0, it means x minus 1 is a factor of f of x. I hope you are following. Right. So you carry out long division to find the quotient, or you can use the identity approach. So according to the identity approach, you write 3 x cubed, right, plus x squared minus 8x plus 4. Then you say it's identical to, then you put x minus 1. Then this second bracket is your quotient, x minus 1 is your divisor. So you're saying the first term of the divisor into the first term of f of x, you get 3x squared. You are saying x into 3x cubed, you get 3x squared, right? But there is an unknown term in between. I'm going to represent it by kx. Then you are saying the last term of the divisor minus 1 into the last term of f of x, you get minus 4. Then to find k, we equate the coefficients of x squared both sides. I hope you are following. So the coefficient of x squared on the left side is 1. Since we have x squared, it means there is a silent 1 here. Then on the right side, you get 2 coefficients of x squared. The first one is going to be obtained if x multiplies kx. X times kx, you get kx squared. So k is a coefficient of x squared. Then minus 1 times 3x squared, you get minus 3x squared. It means the other coefficient of x squared is minus 3. You move minus 3 to the left, you get 1 plus 3 is equals to k. Therefore, 4 is equals to k. I hope you are following. So you now have x minus 1. Then you have 3x squared plus 4x minus 4. So this second bracket is going to produce 2 more brackets for you to factorize it completely. So to factorize this quadratic, you multiply the first term with the last term. You are saying 3x squared times minus 4, you get minus 12x squared. Then you find 2 factors of minus 12, which gives you a sum or a difference of plus 4. You have plus 6 and minus 2. 6 minus 2, you get plus 4. Then 6 times minus 2, you get minus 12. So you have 6x and minus 2x. I hope you are following. Right. So replacing 4x with the factors, you get 3x squared plus 6x minus 2x minus 4. Then you factorize the first 2 terms on their own and the last 2 terms on their own. So factorizing the first 2 terms, you can clearly notice that the highest common factor is 3x. 3x into 3x squared, you get x. 3x into 6x, it gives you 2. Then the highest common factor of the last 2 terms is minus 2. Minus 2 into minus 3x, you get x. Minus into minus, you get plus. 2 into 4, it gives you 2. Now that we have a common bracket, x plus 2, you can factor out the common bracket, x plus 2. Then you'll be left out with the terms attached to the common brackets, which are 3x and minus 2. Therefore, our final answer is going to have 3 brackets. X minus 1, the original factor, and the 2 brackets obtained from factorizing the quotient. And this is your final answer. I hope you are listening. Stay tuned as we move on to question number 3. Right, we move on to question number 3a. It reads, find the product of x to the power of 1/3 minus 2 and x to the power of 2/3 plus x to the power of 1/3 plus 1. So product means multiplication. We are going to multiply the two brackets. I hope you are following. Right, so we are saying x to the power of 1/3 is going to multiply the second bracket. Something like this. Then minus 2 is also going to multiply the same bracket. Plus 1. I hope you are following. So when multiplying these brackets, you need to observe the laws of indices. According to the product law of indices, it says that if you multiply numbers with the same base, you add powers. Something like this. X to the power of a times x to the power of b is equals to x to the power of a plus b. Multiplying numbers with the same base, you add powers. So x to the power of 1/3 times x to the power of 2/3. These are numbers with the same base. So you add the powers if you multiply the two. So you are saying 1/3 plus 2/3, you get 1, which is good as x. Then you move on to the next. X to the power of 1/3 times 2x to the power of 1/3. You get 2x to the power of 2/3, where 2/3 is 1/3 plus 1/3. Then x to the power of 1/3 times 1, you get x to the power of 1/3. We are through with the first bracket. Here, you get minus 2x to the power of 2/3. Minus and plus, you get minus. 2 times 2, you get 4. X to the power of 1/3. Then minus times plus, you get minus. 2 times 1, you get 2. So you are now adding the like terms. So x, there's no another term in x. It means x remains x. But 2x to the power of 2/3 minus 2x to the power of 2/3, you get 0. Then x to the power of 1/3 minus 4x to the power of 1/3, you get minus 3x to the power of 1/3. Then you put minus 2. This is our final solution. I hope you are following. Since x to the power of 1/3 is good as 1, x to the power of 1/3, you'll be saying 1 minus 4, you get minus 3, x to the power of 1/3. But 2x to the power of 2/3 and minus 2x to the power of 2/3, they give you 0. So this is your final result. We no longer have like terms. Let us move on to part B. Solve the equation y to the power of 2/3 minus 5 y to the power of 3rd plus 6 is equal to 0. So this is a quadratic equation. What you need to do is you need to understand that y to the power of 2/3 is good as y to the power of 1/3 or raised to the power of 2 minus 5y to the power of 1/3 plus 6 is equals to 0, something like this. So here you are going to have y to the power of 1/3 here. Then you write y to the power of 1/3 here. Then you equate it to 0. We need to find two terms, which gives a sum or a difference of minus 5 and a product of 6. So we have minus 2 and minus 3. Minus 2 minus 3, you get minus 5. Minus 2 times minus 3, you get positive 6. I hope you are following. So since we have two brackets multiplying each other, giving a product of 0, it means one of the two brackets is 0. So you are saying y to the power of 1/3 minus 2 is equals to 0, or y to the power of 1/3 minus 3 is equals to 0, something like this. You get y to the power of 1/3 is equals to 2. Then making y the subject, you raise both sides with power 3. So that if 3 multiplies 1/3, you will be left out with y. So the first solution is 2 to the power of 3, which is good as 8. Then we move on to the right side. Y to the power of third is equals to 3. Do the same thing. Raise both sides with power 3. 3 times 1/3, you get y. 3 to the power of 3, it gives you 27. Then you are home and dry. So these are the solutions. We move on to question number 4. It reads, the radius of a spherical globe was increased from 11 centimeters to 11,02 centimeters. So the difference between 11,02 and 11 is 0,02, which is the change in radius. We denote this with the delta r. So you are saying delta r is equals to 0,02, something like this. This is delta r, the small increment in radius. All right. So determine the percentage increase in volume of the globe, 6 marks. So the percentage increase in volume is denoted as delta V over V times 100. So delta V over V times 100 is the percentage increase in volume. But we are given 0,02 as the change in radius, not percentage change in radius, but as the change in radius. I hope you are following. Right. So firstly, you need to differentiate the given volume formula of sphere. For V is equals to 4 over 3 pi r cubed. You need to differentiate this to get dV dr first. So how do you get dV dr? You are saying 3, the power, is going to multiply 4 over 3 pi. Then you less 3 with 1. 3 and 3, they cancel off each other. So you get dV over dr is equals to 4 pi r squared. I hope you are following. So we are saying 4 pi r squared is approximately equal to delta V over delta R. Now that delta R is provided by the equation as 0,02, we cross multiply by delta R. So you are saying 4 pi r squared dot product delta R is approximately equal to delta V. But on delta R, I'm going to put 0,02. So you say 4 pi r squared dot product 0,02 is approximately equal to delta V, something like this. Then you multiply, you get 0,08 pi r squared approximately equal to delta V, something like this. I hope you are following, right? But remember, the required is delta V over V times 100. They want you to find the percentage change in volume. So on delta V, I'm going to insert 0,08 pi r squared. So you get 0,08 pi r squared as delta V, right? This is to be divided by the given volume, which is 4 over 3 pi r cubed. Then you multiply with 100. I hope you are following. So on R, you have to put the original value before change, which is R was 11 before changing to 11,02. R was 11. So I'm going to put 11 on R. But you can notice that pi and pi, they cancel off each other. Then R squared into R cubed, you get 0,08 over 4 over 3R. Then you multiply by 100. So put 11 on R. You get 0,08 4 over 3 open bracket 11, then you multiply this with 100. So what is your final answer? You get 0.55%, and this is your final result. I hope you are following class. Let us move on to question number 5. It's expand 1 over square root of 1 minus 2x up to and including the term in x cubed. So firstly, you need to understand the binomial expansion formula, 1 plus x to the power of n. It is equivalent to 1 plus nx plus n minus 1, x squared over 2 factorial plus n minus 1, n minus 2, x cubed over 3 factorial, something like this. Right, so we are given 1 over square root of 1 minus 2x. Remember, square root of a number is raising that number with a half. So square root of 1 minus 2x is good as 1 minus 2x to the power of half, something like this. But remember, according to the laws of indices, if you have 1 over x to the power of a, this can be written as x to the power of minus a, the inverse law. So it means 1 over 1 minus 2x to the power of half can be treated as 1 minus 2x to the power of minus half, something like this. So from the look of things, you can notice that our power n is going to be represented by minus half. Then on x, we are going to insert minus 2x. I hope you are following. So you get 1 plus open bracket. On n, you put minus half. On x, you put minus 2x. Plus, on n, you put minus half. Then you write minus half minus 1 here. On x, you put minus 2x, then raise it by power 2. 2 factorial is good as 2 times 1. So 2 times 1, it gives you 2. We move on to the fourth term. On n, you put minus half. Then you write minus half minus 1. Then you write minus half minus 2. Then you put minus 2x. Raise it with power 3. Divide this with 3 factorial. I hope you are following class. So if we punch this in our calculator, what do you get? The first term is 1. Negative times negative is positive. 2 times 2 is 1. So the second term, it gives you x. I hope you are following. We move on to the third term. You get 1,5, which is good as 3 over 2. So you are writing plus 3 over 2 x squared. Then you move on to the last one, 5, which is good as 5 over 4. So plus 5 over 4 x cubed, and this is your final result. We move on to part B. State the values of x for which the expansion is valid. So remember, the validity of expansion, we use the formula modulus of x is less than minus 1. On x, you put the value that was representing x in your substitution. Right, so the value representing x in our substitution is minus 2x. So you put minus 2x here in modulus. You less this with 1, something like this. Right, but remember, a negative number inside the modulus disappears. So you have 2x in modulus less than 1. modulus of x is less than half. So your final answer is minus half less than x less than half. So this is the validity. Right, we are now moving on to part C. Taking x is equals to minus 1 over 6. Use the expansion to find the value of root 3, correct to 5 decimal places, 2 marks. Right, so to attack this question, you need to substitute minus 1 over 6 both sides, on the left and on the right. So you write 1 minus 2, open bracket, minus 1 over 6 is equals to 1 plus minus 1 over 6 plus 3 over 2, open bracket, minus 1 over 6 squared, plus 5 over 4, open bracket, minus 1 over 6 cubed. So this is the first thing to do, substituting minus 1 over 6 on x on the left side and on the right side. Right. So if we punch this in our calculator, the right side gives you 751 over 864, right? Then on the left side, you get 1 over square root of 4 over 3. You get 4 over 3 if you punch 1 minus 2, open bracket, minus 1 over 6. Right. So since they want you to find root 3, you simply make root 3 the subject of the formula. So here you get 1 divided by square root of 4 is 2, square root of 3 is root 3. Then you equate this with 51 over 864. So 1 divided by 2 over root 3 is good as the reciprocal of the denominator. So you are writing root 3 over 2 is equals to 751 over 864. Therefore, root 3 is good as 751 over 864 times 2. Why? Because you multiply both sides by 2 to make root 3 the subject. So if we punch this in our calculator, we need our answer corrected to 5 decimal places. Right? So 751 divided by 864, then you multiply by 2. What do you get? 1,73,843. So this is your final answer to the requirement, 5 decimal places. Let us move on to question number 6. It reads, the coordinates P, Q, and R are 121, 478, and 6412 respectively. S is a point such that PQRS is a parallelogram. Find the coordinates of S. Right, so you first of all sketch the parallelogram. Remember, a parallelogram is a shape with 4 sides, of which 2 opposite sides, they move in the same direction. So when labeling PQRS, you label the letters with the order or the sequence PQRS. So if you say this is P, it means this is Q, and this is R, and this is S. So you have PQRS. You label it with the order. If you don't follow that order, you obtain a wrong result. I hope you are following. So the point P is given as 121. So I'm going to write 121 on P. The point Q is given as 478. You write 478 on Q. The point R is given as 6412. So you write 6412 on R, something like this, right? Then the coordinates of S are unknown, let the coordinates be represented by X, Y, Z. Right. So I want you to notice something. The property of a parallelogram makes opposite sides move in the same direction and equal at the same time. So it means vector PQ is equivalent to vector SR. I hope you are following. But what is PQ? PQ is equals to OQ minus OP. What is SR? SR is equals to OR, right? Minus OS. Something like this. So on OQ, substitute 478. Then on OP, substitute 121. On OR, substitute 6412. Then on OS, substitute XYZ. Something like this. So we want to create common brackets both sides. Here, 4 minus 1, it gives you 3. 7 minus 2, you get 5. 8 minus 1, you get 7. Something like this is equals to 6 minus X (4 minus Y) and 12 minus Z. So to find X, you are saying 3 is equals to 6 minus X. You get X is equals to 6 minus 3. Therefore, X is equals to 3. Then to find Y, you are saying 5 is equals to 4 minus Y. So it means Y is equals to 4 minus 5, which is equals to minus 1. Then here you are saying 7 is equals to 12 minus Z. It means if you put Z to the left, you get Z is equals to 12 minus 7, which is equals to 5. I hope you are following. So the coordinates of S are X is 3, right? Y is minus 1, right? And Z is 5. This is your final answer. Move on to part B of the question. It reads, the points M and N are the midpoints of PQ and QR respectively. So M, this is M, the midpoint of PQ. Then N is the midpoint of QR. So this is N, the midpoint of QR, respectively, right? Find the unit vector in the direction of MN. So to find the unit vector, you first of all find MN, right? So what is MN? MN is equals to MQ, right, plus QN. MN is equals to MQ plus QN, something like this, right? I hope you are following, right? So what is MQ? MQ is half PQ, of which PQ is 3, 5, 7. So half of PQ, half of 3, 5, 7 is your MQ. I hope you are following, right? Then what is QN? QN is half of QR, of which QR is equals to OR, which is 6, 4, 12, minus OQ, which is 4, 7, 8. 6 minus 4, you get 2. 4 minus 7, you get minus 3. 12 minus 8, you get 4. So here I'm going to write 2 minus 3 and 4. Something like this. Right, so I'm going to factor out half first as a common scalar so that I start by adding the corresponding terms. 3 plus 2, you get 5. 5 minus 3, you get 2. 7 plus 4, you get 11. So you are now dividing each and every term inside by 2. It gives you 2,5. Here you get 1. Here you get 5,5. Which is good as 2,5i plus j, which is your 1, plus 5,5k. So this is mn. So remember, unity vector is good as the vector itself divided by the modulus. So you are saying unit vector is equals to 2,5i plus j plus 5,5k. Then you put a square root, something like this. You write 2,5 squared plus 1 squared plus 5,5 squared. So your final result becomes 2,5i plus j plus 5,5k to be divided by the square root of 37,5. Then you are warm and dry. So this is your final answer. Let us move on to question number 7. Question number 7 reads, it is given that f of x is equals to x squared minus 8x plus 10. Express f of x in the form x plus a squared plus b. Right, so you can complete the square or use the identity approach. So according to the identity approach, you are equating the quadratic with x plus a squared plus b, something like this. Then you get x squared minus 8x minus 10 is equals to, if you expand this, you get x squared, x times a times 2, you get your middle term 2ax. Then the last term is a squared. You add it with b. So we are equating the coefficients, right, of x. On the left side, you have minus 8. Then on the right side, you have 2a. Dividing both sides by 2, it means a is equals to minus 4. Then we are now equating the constant terms, the terms without x. On the left side, you have minus 10. Then on the right side, you have a squared plus b. So you get minus 10 is equals to minus 4 squared plus b. Minus 4 squared is 16. So moving 16 to the left, you get negative 16 is equals to b. This is minus 26 is equals to b. So your final answer is x, a is minus 4. So you write minus 4 squared. Then b is minus 26. Then you are home and dry. Right? Or you can complete the square. We move on to part B. Hence, or otherwise, find the least value of the function. So the least value is the minimum value. The minimum value is the value of y when this bracket becomes 0. So we find the value of x which makes this bracket to become 0. it's x is equals to 4. Right? So if you put 4 on x, you'll be left with minus 26. So the least value of f of x is minus 26. This is your least value. I hope you are following. Right. And write down the equation of the line of symmetry for the graph y is equals to f of x. Right. So to find the equation of the line of symmetry, you can notice that our graph is a U-shaped graph. It comes something like this. It is a U-shaped graph since the coefficient of x squared is plus. Right. So you simply need to find the intercepts or the values of x when y is 0. I hope you are following. So what is the value of x when y is 0? Very simple. You are saying x minus 4 squared minus 26 is equals to 0. You get x minus 4 squared is equals to 26. You get x minus 4 is equals to plus or minus square root of 26. You get x is equals to 4 plus or minus square root of 26. Meaning to say that on the left side, we have 4 minus root 26. And on the right side, we have 4 plus root 26. So the equation of line of symmetry, it passes through equals to x. We need the value of x here, which is the average of the two values. So you are saying x is equals to 4 minus square root of 26 plus 4 plus square root of 26. Then you divide by 2. The average of the two numbers gives you the line of symmetry. Right. So what do you get here? You get x is equals to 4 plus 4, it gives you 8. Then minus 26 plus 26, you get 0. So 8 divided by 2, you get 4. So the equation of line of symmetry is x is equals to 4. So we have 4 here. This is your final result. I hope you are following. We move on to part C of the question. It reads, state the geometrical transformations which maps x squared onto x squared minus 8x plus 10. Right? So you can use the answer that you got from the completing the square, which is x minus 4 squared minus 26. This one represents your image. X squared represents your original. So they want you to set the transformations. So the first transformation here, since we have negative 4 inside the bracket of x, this is translation. We refer to this as translation in the positive x direction. Then the vector is also required. You give the vector, and the vector is plus 4 and 0. So this is the first transformation. Translation in the positive x direction with the vector 4, 0. Right. Then we have minus 26 denotes translation. This is translation in the negative y direction. In the negative y direction, then you also give the vector. Since it is for y, you put minus 26 below. Then you are home and dry. So this is how you describe. So for x, there is a sign change. This minus 4 becomes plus 4. But for y, minus 26 remains the same. I hope you are following. So translation for X is whereby you have a number inside the bracket. Then translation for Y, we have a negative number or a positive number outside the bracket. I hope you are following. So inside the bracket, there is a sign change. You get 40. Outside the bracket, there is no sign change. Minus 26 remains the same. I hope you are following. Right, so I hope you enjoyed today's tutorial. Tomorrow, we are going to continue from where we left. Till we meet again, shalom.